All right, let's talk about something we use literally every second we're online, but probably never really think about. API authentication. It's the invisible force that keeps our digital lives secure. Think of it as the gatekeeper, the secret handshake of the internet. And today, we're going to pull back the curtain and see exactly how it all works. So let's just start with the most basic question, right? When you open an app on your phone, how does it know it's actually you asking for your photos or your messages and not some random stranger? You can kind of think of it like a bouncer at a club. Before they unclip that velvet rope, they need to check your ID, make sure you are who you say you are, and that your name is on the list. The internet needs to do the exact same thing. And that right there is the whole job of authentication. An API, which is just the messenger that lets all our apps talk to each other, has two absolutely critical jobs. First, it has to figure out who is sending a request. And second, it has to check if that who actually has permission to get the data they're asking for. It's all about making sure only the right people get to see the right stuff. Simple as that.
Okay, so to really get how we ended up with the super secure systems we have today, we've got to go back to the beginning. Let's take a look at the earliest, most straightforward ways we did this, the very first digital keys that unlocked the doors to the web. So the first two on the scene were API keys and something called basic auth. An API key is pretty much what it sounds like. It's just a long secret string of text you send along with your request. It's like a secret password, but for an app instead of a person. Basic auth is even more familiar. It's just your username and password squished together and scrambled a bit so they can be sent over the network. Now, both of these are super easy to use, but you can probably guess that having just one single key isn't exactly Fort Knox when it comes to security. Now, that's not to say these simple methods are useless. Far from it. They still have their place. You see API keys being used all the time for things like weather apps or map services, where the data is public and the risk is pretty low. And basic auth, you'll still find it in a lot of internal company tools or on older systems that haven't been updated. The main thing to remember is that their security is kind of low to medium, so you only want to use them for specific, less sensitive situations. But as our digital world got way more complicated, we needed something a whole lot smarter. And this brings us to a massive leap forward in both security and just efficiency. It's like we upgraded from a simple metal key to a high-tech, tamper-proof ID badge. And that is the JSON Web Token, or JWT for short. What makes this thing so cool is that it's completely self-contained. A JWT is this compact little token that has all the info about you packed right inside it. After you log in, the server gives you one, and because it's digitally signed, nobody can fake it. And here's the best part. The server doesn't have to remember you anymore. It just looks at your ID badge, checks the signature, and knows you're legit. This makes it so much faster and easier to scale for modern apps. So here's how that works in practice. It's this really elegant three-step dance. Step 1. You log into your favorite app with your email and password, just like always. Step 2, the server says, yep, that's them, and hands you back your own personal signed JWT. And step 3, from now on, your app just shows that JWT every single time it talks to the server. It's your passport, proving who you are without you ever having to send your password again. And if we could crack one of these tokens open, you'd see it has 3 distinct parts, all separated by a dot. You've got the header, which just says what kind of encryption was used. Then you have the payload, which has the actual info, like your user ID. And then the most important part, the signature. That's the secret sauce, the cryptographic proof that says, yes, this token is real and no one has messed with it. Okay, now we get to the big one. The protocol that really, truly changed the game and made the connected world we live in possible. This is the absolute genius idea that lets you give an app permission to do things for you without ever sharing your password with them. And its name is OAuth 2. I guarantee you've used this hundreds of times, even if you've never heard the name. It's the industry standard for what's called delegated access. Every single time you see a button that says log in with Google or continue with Facebook, yep, that's OAuth 2 doing its thing. It's the magic that lets us securely connect all our different services together. So how does that login with Google button actually work its magic? Let's walk through it. First, the app you want to use bumps you over to Google's website. Second, you're on a page you recognize and trust, and you click Allow to grant permission. Third, Google instantly sends you back to the app, but with a secret, one-time use code. Fourth, and this happens behind the scenes in milliseconds, the app takes that code and trades it with Google for a much more powerful access token. And finally, the app uses that access token to ask for just the data it needs, like your name and email. And this right here is the whole point. I mean, this is so profound for our security. You are giving an app a very specific, limited permission to get a tiny piece of your data, but you never, ever hand over the keys to your entire digital kingdom, your password.
And of course, the evolution doesn't stop there. There's another protocol called OpenID Connect, or OIDC, that builds right on top of OAuth 2. So think of it like this. OAuth 2 gives an app an access token. That's the key to a specific room, telling it what it can do. OIDC adds an ID token on top of that. That's like a verified driver's license that proves who you are. This powerful combo of permission and identity is the absolute gold standard for big companies using single sign-on or SSO.
Whew. Okay, so we have traveled all the way from simple keys to this complex world of delegated trust. So now let's get practical. How in the world do you know which of these tools is the right one for the job? Let's break it down with a little scorecard. This is the question every single developer has to ask themselves. You've got all these different methods in the toolbox, from the super simple to the really complex. So which one is the best? Well, as you can probably guess, the real answer is, it depends. It totally depends on what you're trying to protect. And this chart is basically our cheat sheet. It lays it all out for us. You can see the trade-offs so clearly. For a basic public API, yeah, an API key is probably fine. Just doing some internal testing, basic auth can get the job done. Oh, and you see session auth here? That's the classic way traditional websites work, where the server just remembers you. For a modern mobile app, JWT is a fantastic fit. Need social logins? OAuth 2 is the only way to go. And for really high-stakes stuff like banking APIs, you'll see things like HMAC, which is a super secure way of signing every single request. Each tool has its perfect job. So if there's one thing to take away from all this, it's that authentication isn't a one-size-fits-all kind of problem. Not at all. It's a whole spectrum of tools. And picking the right one is always about finding that perfect balance between how much security you need and how much complexity you're willing to handle. And that brings us to the end. We've watched authentication evolve from a simple secret key to these incredible protocols of trust. But you know this journey is far from over. As all our devices, our homes, our cars, and our very identities get more and more connected, what's the next step? What does the next evolution of digital trust even look like? Definitely something to think about. Thanks for joining me.